Hey, topic of lunch, math and history, and we are going to take a look at the rational root theorem. So wait, what is the rational root theorem? Well, in a complex idea, it looks like, whoa! So that is a giant formula, and what's happening is it seems like you have an m, then you have like m minus 1, and x plus 1, and it says must be real numbers. But how do we simplify that gigantic formula right from there? Well, here's what happens. Any rational root expressed in lowest terms of p divided by q helps to find all possible zeros, where p is the factors of the constant and q is the factors of the leading coefficient. So what happens is this strategy is good for when you can't really factor anything out, when you can't really simplify it out, and all you have to do is try to use this method right here and find all the possible zeros so you get everything laid out in factored form. So let's try to find a problem where we can actually apply that. And in this video, we're actually not going to find the final answer, because like many other, this is a tool that will help you get to the answer. So once you simplify it, it will get easier and easier and easier and easier and easier and easier. Such as, so right over here is a gigantic polynomial, when the function of x is 2x to the power 5 minus 12x to the power 4 plus 21x to the power 3 minus 30x plus 9. And what the rules literally stated is that we have to find p divided by q, where p is the factors of the constant and q is the factors of the leading coefficient. So right over here, we can say that the letter p in this case scenario is 9. So we're going to focus on the number 9. So p can have factors 1, 3, and 9. Now, all we need to do is take a look at q. And q is the factors of the leading coefficient. So what is the leading coefficient? Yeah, the leading coefficient in this case scenario is 2. So our q is going to be 1 and 2. But here comes the hard part. This step right here that we're going to show is the reason why many people dislike the rational root theorem, because there can be different possible solutions. What we just did is we grabbed up factors from the constant and factors from the leading coefficient. Therefore, there can be many possible answers that will get us to a 0, but we don't know. That's because we have to do p divided by q, positive, negative, 1 divided by 1, positive, negative, 3 divided by 1, positive, negative, 9 divided by 1, positive, negative, 3 divided by 1, positive, negative, wait, we don't need that. So we did all these divided by 1. Now we have positive, negative, 1 divided by 2, positive, negative, 3 divided by 2, and positive, negative, 9 divided by 2. So you know how I kept having to pause the video and check where I am? The rational root theorem you can get lost in, because we have to do this divided by that, and then that divided by that. But the problem is, if you have a factor, like many factors, you could have a lot of scenarios, positive or negative, and have at least one get to a 0. In some case scenarios, in college, you can get up to like 60 or more. But in this class, you might have a maximum of at least 6, I think. Maybe 4. Our teacher's doing 4. So the question is, positive or negative, what numbers that insert in for x is going to bring me to 0? Well, our pre-calculus class literally did all of them, but one person did one. And here's what happens. We found out that 3 is the lucky answer. So that would be 3 divided by 1. And yeah, but why? If we put 3 into each of the problems, let's try and solve it all out using a calculator. So, we have right here 125, because that is going to be 3 to the power of 5. Actually, nope. 3 to the power of 5 is 243. Guessed it wrong. And then we have to multiply that by 2. And we get 486 minus 3 to the power of 4 is 81 times negative 12 is negative 972. Then we have the x cubed. So 3 to the power of 3 times 21 is 567. I'm going to add them. Then we have 3 times negative 30. And that is going to be negative 90. So minus by 90. Plus 9. This is a really big mess. But what happens is when you sum these up together, you will get a 0. And which means that you put something in for x. So in this case scenario, x is equal to 3. But your math teacher wants you to simplify it to the fullest. So what would happen is since you got x equals 3, because that works in getting a 0 as a y, that means you would have to divide this by the opposite. So let's see what happens when you divide by the opposite. We have to do synthetic division because we have a perfect 0. So what happens right here is we put 3 back as right behind the multiplying box. We turn it back into positive 3. So now we have 2, negative 12, 21, 0 because we don't have an x squared, negative 30, and 9. So when you do everything out, drag the 2. 2 times 3 is 6. Negative 12 plus 6 is negative 6. Negative 6 times 3, negative 18. 21 plus negative 18, negative 3. Negative 3 times 3 is 9. So negative 9. Actually positive 9 because this has to be positive. So we have 9. 9 times 3 is 27. And we get negative 3. And negative 3 times 3 is negative 9. And 9 minus by 9 gives you a remainder of 0. So we can say already that this is a perfect 0. And what you have left is 2x to the power of 4 minus 6x to the power of 3 plus 3x squared plus 9x minus 3. So that is going to be what you have left. And you can try simplifying it. Try to go through all that rational root stuff, which I wouldn't really recommend. But we're going to stop right here because basically what rational root theorem does is if something is too hard, or you can't really simplify anything, and you have no zeros, or the teacher never gave you any zeros, then rational root theorem would be the last result. But don't use it if you absolutely don't have to, which I wouldn't recommend doing this if you don't have to. I hope this video has helped you understand rational root theorem. Thank you for watching Top Analyze Math Industry. Like and subscribe.